Hi, Chris DeLeon here for LMC 6310, Computers and Expressive Medium. Once again, I'm a programming TA for this course in digital media at Georgia Tech. I'm going to make another programming video here using as our development environment processing, which is free from processing.org, which you should check out if you haven't got it yet. And if you're new to the video series, this goes back, I think it's probably about the 12th video or so. There's some earlier ones in the series you may want to catch up on, or feel free to jump right in if you're comfortable with that. Now the format I've changed to is to provide steps. And in my previous video, I think I took too long basically reiterating the verbal steps. So here I'm just going to read them once. They're on the screen, and I'm going to encourage you if you want to pause and work on these steps on your own before, and then I'm going to type out the solution and walk you through the way I would do it. So step one, open processing. You're going to set your window to about 644-80-ish. Not terribly important, it's exactly that size. You're going to add a cyan circle, which will be the player. That's going to move smoothly in cardinal directions while arrow keys are held. We've got a pattern for that from previous projects we worked on. Circle width should be around 20 pixels or smaller. Again, not a big deal. Create a mostly white image. For this, you're going to want Photoshop or from GIMP.org, that free tool, MS Paint, anything will do, with blobs of solid colors, black, red, blue, and green. You're going to want to save this as PNG or basically just not JPEG. JPEG's a lossy format. You're going to lose data. We're going to be using those color values as indexes into like a collision system to know whether we're passing over sand or water or a black hole or what. Lava pit maybe. We're going to load that image and display it as the background under the blue circle. So the whole screen is going to be our image we drew. And of course, like noted here in the hint, it's going to be handy to make that the same dimension as your application's window size. So in this case, 640 by 480-ish. We could make a bigger one that scrolls. Here we're just going to worry about getting it to work at all. We're going to then want to check the color of the background image at the player's coordinate. And if it's white, don't have any effect. If it's black, reset the player back to the start position. Or actually, sorry, bump the player back to avoid walking over it. So basically, we're going to treat black as a wall. If it's red, blue, or green, do something different. And so we might slow it down, speed it up, drain health, transform it into a different creature, graphic, whatever. We just want to have different effects based on which color is under the player. We're going to make an array list of bad guys that'll react to the color cues the same way as the player will move automatically. And we're going to use random movement for this, which will be perfectly fine. We're basically just going to pick a direction and wander that way, but you can do it however you want. And color them differently than the player so the player can easily tell which character on the screen is theirs. And then lastly, draw, load, and show a different, prettier version of the background image instead of the color key version that's used for collision detection. So the idea here is that even though we want to have solid colors of black and red and blue and green to detect different collision areas for the map, we don't necessarily want to show it to the user because it's not a very attractive image. So we can display a nicer image. Maybe have trees decorated on it or grass drawn or everyone represent it more visually, even have words and labels. Whereas we'll still be doing collision detection against the solid color image, we'll have a separate image we're going to load and display. So if you're up for giving this a shot, I totally encourage you before you follow along the video, try to do this on your own. Pause the video now to keep the instructions up. If you can't quite read these, this is uploaded at 720, 1280 HD. You should be able to use the gear icon on YouTube to get a higher resolution version of the screen in case you're having trouble reading this text. And I'm assuming by now that if you haven't paused or if you've already worked on or something, you're ready for me to show you my way of doing it. So, all right, so let's move that aside. I'm going to shrink this down so I can keep the steps on my screen, but I'm assuming you are done reading them for now. All right, so I've opened processing. I'm going to open the window. Okay, here's processing over here. Just create a new sketch. Let me increase my size, then we can give to the text I'm typing. Okay, set the window size to 644-80-ish. As always, we have a void setup and a void draw. Setup called once the program starts, draw called every frame. We're going to set the screen resolution to 640-480. I'm going to press play just to confirm that everything works as expected. So far, so good. Okay, let's add a cyan circle that moves smoothly in cardinal directions while the arrow keys are held. Remember to draw a circle, we use the ellipse call, just with the same values for the width and the height. And let's say we're going to be at player X, player Y, and so it could be 20 pixels, and that'd be fine. We're going to now need these to be variables, since we expect them to change while we hold down the key. As I often like to do when we're working on beginning programming, I'm going to encourage sort of for now, work at a sloppy, global fashion. We'll organize as we move forward as it becomes useful to us instead of just that by rote habit or some sort of abstract notion of elegance. Okay, so we have a cyan circle. Oh, we have to make it cyan. Remember, so we have red, green, and blue are options for fill, and cyan is full green and full blue with 0 red. So that's no red, full green, full blue, 0 to 255 out of each. We should have a cyan circle at whatever these coordinates are. Let's just give it a starting position, 50-50. Doesn't really matter too much. When we press play, we should see, let's go and save our sketch first. I'm going to call this color key demo. Press play. There's our cyan circle. Okay. It needs to move smoothly in cardinal directions while arrow keys are held. Okay, well for that, I am going to create a new tab. I'm not even going to create a class for it though. I'm going to call it keyboard. So remember, to create a new tab or a new file, I would click the arrow, new tab, named it keyboard, and pressed enter. And this is just going to allow me to keep separate my logic from my keyboard. So let's say hold left, hold right, hold up, hold down. Okay? Now remember that we have built-in functions in processing, where if we write functions for key pressed and key released, it'll automatically call key pressed independent of which key got pressed, and inside there it's going to have set key code to the key if it was a button like an arrow key, or key to the character. So in here we could check and see if key equals left, we could do, or if key code equals left, or if key equals J, we can respond to the J key. Again, key code is used for arrows, an enter key and spacebar. I guess so. Spacebar, we do it like a character, just like a letter with a space. But what I like to do for this, so I can have a common set, is I'll write a helper function called setSignal boolean set2, and in here I'll check and see if key code equals left, then we're going to update hold left to equal set2. Let's go ahead and set each of these to false, by the way, at default, which I imagine it probably does automatically, but it's good to be explicit. The general rule, rather than to assume that numbers started 0 or boolean started false. And now when the key gets pressed, I'm going to send through a true if the key was pressed and a false if the key was released. And so inside setSignal, it'll update left key based on whether or not it was called from being key pressed or key released, because I'm passing a different value, true versus false, as my set2 argument. I'm going to do the same thing for each of the different directions, so we can move in different ways. Right. Right. Okay. I'm going to copy paste those and switch them out for up, down, up, and down. And again, the important thing to know here is that key pressed and key released, part of why they're turning blue is that they're built into processing to be called automatically upon key press and key released events. And that key code is automatically updated by processing to be which key we've pressed. That left, right, up, and down in all capitals are constants, also again built into processing to recognize or match to different key directions that can be pressed for the arrows. Okay, let's go back to our main sketch file. I'm going to separate out into a different function, player movement. In fact, let's go ahead and move out player drawing as well. Void player draw. As always, got a void because I don't have a return type. Parentheses because it's a function with no arguments. Braces to show the section that this function is going to apply to. I'm going to put that label here. I'm going to move the fill and the ellipse using cut and paste back into the function. And this is just going to help both keep our code tidier as well as self-document, so we can remember what's happening here. That's the part drawing the player, and here's the code for it. Now let's also have a line for move player. Oh, we want to be consistent. Rather than player, we had player draw, so we should have player move. Okay, there we go. And again, so it's going to jump from here. Draw gets called every frame. It's going to move and then draw. Move and then draw each time. Here in move, we want to check and see. Let's check these keyboard handles. If we're holding left, let's set a variable up here so we can have a, well, see, because here we could say player x minus equals 2.0, or, because, you know, when we hold right, we're going to go in the other direction. We're going to make it increase by 2 pixels instead of decrease. But we kind of want to keep those all the same, so let's say speed equals 2.0. Pardon those F's, I've been in Unity a bunch recently. Okay. Now we can define one number at top by this label, and within the scope of this function, remember it only lasts for this function because we declared it here as a variable that is just sort of local to this scope. If I hold left, we're going to decrease our x coordinate by a certain amount. If I hold right, we're going to increase it by a certain amount. Same amount in either case. And again, kind of copy and paste it. Remember to change your x's to y's, up and down. And up, again, because we're inverted from a geometry coordinate system, decreasing y brings us higher on the screen because we're lower to the memory addresses. So holding up will raise us on the screen, holding down will lower us. Now the last thing, I'm not sure if you've noticed this, but we're not erasing the background yet. So right now we're going to smudge, which we often show at the start of, I had a typo here. So set2 was the Boolean signal. Sorry about that. Just gonna little copy paste there right there. Just got rid of the L's in my set signal because this should match the same name as it is in the argument. Now when I press play, again, so right now we're smudging. It's leaving behind a trail not because we've written special code to make it leave a trail, but because we haven't bothered to write the code to erase what's behind it. Oftentimes we would use a background call or a fill and a rect call to blank out what had been drawn in previous frames to avoid the smearing effect. In this case we won't need to because we're going to be pasting over every single frame a whole background image that's mostly white that's going to cover every pixel from the previous frame. That's going to be our step 3. But right now we're done with step 2. Now I also want to point out, so you saw there I had a little typo, I pressed play, had to go back and fix it. Don't sweat that stuff. It's a normal part of programming. I've been doing this forever. Debugging is programming. It's something our professor, Dr. Murray, in the other class likes to say. You just got to expect little errors to come up. It doesn't mean you're doing it wrong. That's just how programming works. That's why the compiler gives you the feedback it does, so you can trace out the line and try commenting things out and get to the bottom of the problem. That's one of the most important skills for programming. Okay, so pardon the digression. Okay, now we're going to create a mostly white image. I'm going to use Photoshop. You could use GIMP.org, which is a handy tool for this kind of purpose. MS Paint, whatever. If you don't have a tool in your system that lets you create and edit image files, it'll really behoove you to find one. So I encourage you to look one up if you haven't. I'm going to open up Photoshop here. I'm going to say new. And so our image is 640 by 480. That's the size of our screen that I've made. And background contents, rather than transparent, I want white because I want this to blank out the screen behind it. All right, now I said I want to have some blobs. Now notice here, I could use a brush tool, which is fine around the edges. I'm going to use a pencil because that's going to work better for drawing hard edges. I don't want to have fuzziness and blurring and airbrush around it. I just want distinct color regions. So I want a region with some black circle. My color swatch is off the screen, but I think you can picture that I'm just changing colors. I've got a black circle, I've got some red, gonna get some blue, and just for kicks I'm gonna use the lasso tool. I've turned off anti-alias, again because I want to use solid color regions right now, which won't look as nice, but it'll be handy for collision detection. I'm gonna change that color here, it'll let you see my color swatch. Just change it to solid green, paste. And now different tools will give you different ways to do it. In Photoshop I'm gonna window info. And that's going to let me mouse over. Check out here my my RGB values in my info pane. See how that's 0, 255, 0, 0, 0, 255, 255, 0, 0, 0, 0, 0, and 255, 255, 255. Those are the values that we're going to be looking for inside processing to figure out what color of pixels underneath us. So you want to make sure that those are pure as can be. They don't have to be exact depending on how you write the code, but those are the numbers we're going to be comparing against in processing when we use the pixel get function. So I now need to save this image, and I don't want to save it as a Photoshop format. Photoshop's PSD format is a complex format with all kinds of information about layers and so on. I'm going to save it as a PNG, which is one that processing can also read, and is a simpler format. I'm going to go to my processing sketch folder. So when I saved the processing sketch, I created a folder. If you haven't saved your processing sketch yet, you're going to need to, so you have a folder to put this file in. I named my sketch color key demo, so that's the folder it created. And now in here I need a data folder. I'm going to click new folder, call it data. You theoretically can dump image files in the same directory as your PD files, as your actual sketch code files. It's just sort of not as good as far as staying organized. Data is really where it's supposed to go. And I'm going to call this mapkey.png. Again, we'll make sure the format's PNG. Don't just name it .png, you should make sure the format is. If you're in gimp.org's tool, I think actually the extension there might be used to decide what format to save it in. Interlaced, doesn't matter either way anymore. So there's our file, it's been saved. I'm going to exit Photoshop. Alright, so we've completed a mostly white image with blobs of solid colors. So that was step 3. Now step 4 is to load that image and display it as the background under the blue circle. Okay, so let's load that image. pimage, which is the format used in memory by processing to keep track of our file. So we've made that image file, but now we have to load the file into memory and then draw it to the screen. So let's call this color map. I could, of course, call it map key. I'm just trying to avoid using the same names as the file to show you there's no special connection between the variable name, which is invisible outside of the code, and the file name that we're loading. So pimage, I'm going to call it color map, although I'll camel case it, capital M, color map. Now in setup, we have to load that file, for which I'll say equals load image. And here's where I'm going to say the name, which I believe we called it mapkey.png. Find out soon enough if I'm wrong about that. So I've color map in setup, so it only needs to load it once. We don't want to do this in draw, because I would load the file constantly from the hard disk. We're going to load the image once in setup. And now at the top of draw, so at the bottom of our file, I'm going to say image color map 00, which is going to display the image color map at position 00. We're in the top left corner of the screen. So it should blank out the background each time. There we go. You can see I've got my cyan circle moving around, and I've got those color blobs that we drew in Photoshop or, like I say, gimp.org or MS Paint or whatever tool you're choosing to use. So I can move my circle around on it. Okay, we're done with step 4. Now here's the kind of the heart of the program we're writing. Step 5. Check if the color of the background image at your player coordinate. And if it's white, do nothing. If it's black, bump the player back to avoid walking on it. If it's red, blue, or green, do something else. Okay, so how are we going to set that up? There's this handy function we can use called get that we can do on the pimage. So here inside player move, let's first make it so if we try to step on black, it'll bump us backwards. All right? So to bump us backwards, we could try to undo the previous move by figuring out which key we're holding and reversing that speed. I find the nicest, easiest way to handle that is to at the start of player move, say was x equals player x, was y equals player y. This way we're saving the coordinates of where the player was before the attempted move. And if we calculate that after taking a step we're then on black, we can undo it by simply setting player x back to was x, or whatever the value was, before we had a chance to have made movement changes to the position through our movement keys. So again, this will only last for the duration of player move function call. So these numbers will be forgotten as soon as we get to the bottom brace here at the end of the function. But that's all we need it for, because down here we'll say color, sorry, lowercase c, under player equals, let's scroll down, color map, which is our image, dot get player x, player y. And that's going to get us back the color value under the player. Although I believe, yeah, we're using floats for the player position. So we will need to cast those to integer, because get, quite sure, yeah, get wants ints. You see I press play to show they are wants integers, not floats. Don't sweat it. We just have to cast those, which means we put this left parenthesis int, right parenthesis in front of it. So it tells the computer, okay, I'm aware of the fact this is not an integer already. I like explicitly for the computer to cast it. So if this was 3.6, treat it like 3, that's fine for our purposes. We don't actually care, you know, we know there's not values of colors between the pixels. It's okay to truncate it into an integer. So now we have the color data, and the way we can access each channel off of it is we can, there's commands red on the color, green, and blue. And that'll give us back the 0 to 255 as a float in this case for the color value under us. So for example, we could say equals equals 0. It's nice to avoid using equals equals to floats just because of precision when you get to larger numbers. So I'm going to use it as a little margin of error. So less than 5 is going to give us some margin. So if there's a little bit of gray, it'll still count as black enough. So if there's not much red value there, And there's not much green. Remember, we're looking at the color of the same pixel under the player. And also, there's not much blue. As always, remember it's safe for me to do new line breaks like this because code doesn't care about white space. It can't tell a space from a new line from a tab. It's just how we stay organized. The double ampersands mean that all three of these statements must be true. The pixel under the player must be less than 5 red, less than 5 green, less than 5 blue, 5 out of, again, 255. So remember that when we open up our file in Photoshop, map key, watch again in the info pane, when I mouse over different colors, this one has 255 green, 255 blue, 255 red, 255 of all three. Again, I'm talking about over here in the info pane. When I go over the black, it's all zeros, it's all very low. That's what makes it dark. So if all three of them are less than 5, then we're on black. In that case, we can infer that we must be over a dark tile, so we're going to undo the player's past movement of the last time we held down these keys, this frame. We're just going to say player x equals was x, player y equals was y. That's going to bump the player back to where the player was at the start of this function call before those arrow keys had their effect. When I press play, sure enough, I can no longer walk on top of the black area. Let's see there that I'm unable to. I can get a running start, doesn't matter. Unable to get around it. Okay, now let's have these other colors have some effect as well. Now, for example, let's say we want to have it change our speed. That's going to be one of the easier things to change. Whereas this one we checked after the player moved. To change the speed, because the speed is used up here, we want to change the speed before the hold key checks. So I'm going to copy and paste that color under player code up here. Because we already declare color now at this part of the code, I'm going to remove the variable name down here, so it's just going to reuse that color value. However, I'm not going to comment out or delete this part of code because here player x and player y are after the movement. So they very well could be different than they were before the hold key code was checked. So again, so it's important we're still updating the color under player color value in order to check and see if we've walked onto black already, in which case we could undo it because we've found a collision error in terms of walking onto black. And that's actually, by the way, a really common way to handle collision detection in games, to figure out if a car intersects with a wall. Rather than try to predict where the car is going to be next, we'll often let the collision happen one frame in code. And it's easier to detect if it's already happened because it's just finding the overlap and then bumping it back enough to prevent the overlap before it comes time to actually draw the result of that movement. So that's all we're doing here. So again, still getting the player color updated after the movement, but before the movement, so we can adjust the speed, we're going to get the color of where the player is currently at. All right, and so now let's first check and see if the player is over white, which remember means 255, 255, 255, or I'm going to say greater than or equal to 250, or white enough. Okay, and here I'm going to make a note, on white, do nothing. And the reason why I do that is because that way, having ruled out that we're not on white, we now can assume that if red is above 250, then we're on red specifically, because we know our only colors are red, green, blue, black, and white. We know that this is going to be a useful way to narrow it down. So let's say if we're on red, let's triple our speed, something noticeable. If we're over green, and again, I'm picking greater than or equal to, not less than, because I want to know if we're... So we've already ruled out we're not on white, which means that if we have a bunch of red, we can assume we don't have green or blue. If we're on green, let's slow us down, again, significantly, so we can see the impact of where we're at. And blue, let's reset the player. Now, how to reset the player? We just have to set player x and player y to the original values. And so here, let's make a function called reset player, which we're just going to call before we've written it. As well as, here we're going to return. And the reason we're going to return is because if we don't hit return, it's still going to evaluate the rest of this code, which could include bumping the player back if we reset them to black or something else, which isn't what we expect. Return is just going to bail out of the function here and consider this function's evaluation done. Except on blue, reset the player, and quit. Which is going to be that return's done. Which is just going to skip the player movement code for this one frame. So reset player, let's scroll back up. Here we had set it to 50 manually. Let's do this. Let's create a void reset player with our braces. Let's say player x equals player y equals 50, which is the same thing that this accomplished. I'm going to erase those so we don't get confused about where in the code we're doing the initialization. Otherwise, that number would be quickly stamped over as soon as we called reset player. And then I'll call reset player in setup. Reset player here in setup with a semicolon after it is going to set those values to 50 when the program starts, as well as when we step on blue. So if everything worked as expected, and we'll see if it did. And again, don't feel bad if your code doesn't work initially. If you got a typo somewhere, just part of programming. I've been doing this for a while, and I've already written this program in advance to prepare. All right, so green is definitely slowing my character down, and blue causes it to reset. If I step into the water, if you will, it resets me. Black, I can't walk over at all. And red speeds me up considerably. So I move fast through red, I move slow over green, blue resets me. And again, you got to think about metaphorically, okay, this might be lava pits or water, spikes, brick walls. And you could draw a much nicer map. This is, of course, just a demonstration of using color key as a way of handling collision detection data in a non-grid, non-tile style of map. All right, so we've got those working. Now the next step is going to be to make an array list of bad guys that react to the background color cues the same as the player, but move automatically. We're going to color that differently than the player. Our first step for that is we're going to do a little bit of refactoring. Remember, refactoring is where we change the code in such a way that it still does what it did before. It's just a little bit better organized, so we're better prepared to make changes or adapt or maintain it. So here, we've had our player code so far mixed in at a global level in the same file as our main code. To alleviate that, I'm going to click on the arrow, go to New Tab. I'm going to make this a, what am I going to call this? Unit Entity Actor. We'll call it Actor. Okay, I'm not even making a class yet. I'm not even going to deal with the class yet. Let's just move over all the player variables and code into Actor, which our processing lets us do. It basically just railroads all these files into one major global. So I moved over float player x and player y, so the player position is now an actor. And I move over the reset player function over there into actor. What else have we got? So we still want to leave this in setup because it's still calling it. It's just going to call it from the other file. Player move and player draw both definitely belong over an actor. I'm going to select those. I'm just holding shift and the down arrow to go select these lines. Using Command X and Command V to cut and paste, or Control for if you're on Windows. Okay, so I've now got void reset player, void player move, and void player draw all in the actor tab, which we're going to change, of course, to player soon. We're going to change the player to the actor, which really simplifies our main source file to just have the map, size, map loading, which we really could put in its own file if you felt like it, but there's not much going on there yet. Displaying the image for the map, moving the player, and drawing the player. So far, so good. And when I press play again, it should do the same thing. It's just that our code's a little better organized, which is going to help us expand it a bit more to have an array list of bad guys. Okay. So now let's change this player thing into an actor, into its own class. Class actor. So I indicated it's going to be a class. I named it actor. Brace is going to open up the whole class, and before I do anything else, I'm going to scroll all the way to the end and close that class with its own closing brace, because remember that has to still wrap all the functions and variables for that class. I'm now going to fix my indentation, because otherwise these all stay left bound, which avoids we need a clue that we're inside the actor class where these variables and functions live. We could just go to Edit, Auto Format. I'm partial to manually handling indentation in order to stay organized in my own way. So I'm going to select all the lines except the top and the very bottom. I'm going to use Command and bracket, or remember also Tab and Shift Tab can be used to bump everything over or back in to stay organized. Okay, so we got all those in there. We no longer need this player X and player Y. Let's just call it X and Y. Likewise for reset, X and Y. I'm going to remove player with me. Move me. Reset me, move me, and draw me. Replacing X and Y in each case. Player X and player Y with just X and Y, because those are now our local variables. X and Y, X and Y, X, X, Y, Y, X and Y, Okay. Now over here we're going to have to declare a new actor. The player equals new actor. Inside this class we're going to have a constructor. Remember, constructor just doesn't specify a return type. We're going to call resetMe manually there for the actor itself, which means we can get rid of this call in setup. And now down here we have the player.moveMe and the player.drawMe. I think I kept the capital M and D. Nope, lowercase them, camel case them. That's fine. M and D. I want to press play. Let's see. Oh, reset player. Reset me. That sounds right. And here again, doing the exact same thing it used to do, except now we can expand it to have an array list. Remember how we handle this? Array list enemies equals new array list. Okay, let's fill it up with some. Int I equals 0, I less than, say, 12, I plus plus. Enemies.add new actor. It's going to add new actors to it. And then we also still need to iterate through to draw and move all the enemies. Equals 0, I is less than enemies.size, I plus plus. Enemy, or actor. Each actor equals enemies.get at I, casting that as an actor. And then on each one, we're going to, just like we did for the player, have to draw it and move it. Okay? And now initially these can't move on their own just yet, so we have to change our constructor. Let's have a Boolean, which is just a simple true or false, called isAI. Okay? Boolean CPU control. isAI will equal CPU control. So when we declare the player, we can say false. When we declare the computer ones, we'll say true. And now for isAI, in our movement code, right? So here's where we handle the movement code for the player. If isAI equals false, I'm going to encapsulate within the scope of. So if the computer is not told to control this unit, then the keys will allow it to be moved. Else, okay, let's see, how do we want to make the computer move randomly? There's a few different ways we can do this. One of which, let's just have it pick a random heading. We'll just have these variables live on it. AI dir and int frames till AI change. Okay. And now the way this is going to work is we'll say every frame we're going to subtract from that. If it goes less than 0, random, say 120 frames up to random. And it's going to then select a new random value for itself to point in. So this way, every between 20 and 120 frames of the application running, the AI is going to pick a new direction for itself, which we can then switch on. This is going to look like a lot of code. There's going to be a lot of copy and pasting. There's more elegant ways to solve this, but under the circumstances, just trying to do a quick demo. All right, so 0, 1. So let's have 0 be going east, 1 be going southeast, 2 be south, 3 be southwest, 4 be west. You just see I'm just working through each of the 8 directions. 5 be northwest, 6 be north, 7 be north. Let's see. So minus, 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 plus, and minus northeast. Okay, that should give us each of our 8 directions. And if the other thing we're going to want to do is to make sure the character stays on screen, right? So let's add one here called bounds check. It's going to keep our characters from wandering off, which is going to avoid any sort of illegal checking where the image is not. Void bounds check. If x is less than 0, x equals 0. Same for y. Oops. I'm running out of time, which is why I keep watching that clock. With -1. We're just going to keep it on the screen. That's going to avoid illegal checks. From float to int. Okay, we're going to cast that in at random. I'm going to press play. Oh, they're drawing in a different. They're not drawing a different color. So let's do. Remember, that's why we have this. Is AI. Let's go down to where we pick cyan for our player. So our player is still cyan, whereas AI will be, let's say, yellow. I'm going to press play. There we go. You see we've got some AIs, and you'll see that they also won't walk over the black. They'll have the same speed effects, and the blue will also reset them, just like it does for the player's character. Now the last step is to draw, load, and show a different, prettier version. So let's try that. Let's load up our key in Photoshop. It's just a starting point. And now there's different ways we can handle this. For sake of time, I'm just going to run some filters on it. Say something kind of nice, which of course Photoshop filter is the wrong way to do it. Here's something, filter, mass relief. What I want to show though is that we don't actually need the color data anymore. We can do sort of arbitrarily nifty things to it, assuming this was nifty as opposed to crummy. Let's see, sketch. Let's go ahead and do this. I don't know why I'm so drawn to bas relief, but that's what it's going to be. Okay. Edit, fade note paper. Alright, so the point being, this could be whatever kind of image we want. We're going to save it though as a different image name. I'm going to call this map pretty instead of map key. Save. Okay, now at the top of our program, we're going to load another one called pretty map. We're just going to specify another image variable. We're going to load map pretty. And then nothing else changes except when we draw the map. Instead of drawing color map, we'll draw pretty map. But notice that in our actor code, we're still going to be doing the color checks on color map. So we do collision checks against color map, but we draw a pretty map. What that allows us to do is have a nicer looking background, which could have geographic or political lines or decoration or shadows, however we want to paint a prettier picture. And then otherwise, it'll still have this speed up, slow down, so we'd want to color this to look like lava or look like caves or swamps or whatever would have the effects we'd expect. So that's the 7 steps that we have for our program. Hopefully this has been helpful to you. If you feel a little bit lost, again, I recommend you check back to the earlier videos in this series from 6310, Introduction to Real-Time Graphical Programming Using Processing as sort of the skills technical side of the course. If you have any questions, by all means let me know by email. I'm Chris DeLeon for Digital Media at Georgia Tech. Thanks again for tuning in. And if you haven't subscribed, ask that you do. It helps me out, and of course there should be more programming videos coming your way soon. Thanks. Bye-bye.